Today we are going to see the last special product that it's called binomials with or to the n exponent. For solving binomials to the n exponent, we are going to use what it's called the Pascal's triangle. In this case, we need to focus like the Pascal's triangle will help us to know the coefficients on every one of the terms when doing a binomial to the n power. So let's see how can we create the Pascal's triangle and how to use it for solving binomials to the n exponent. In this case, if we see here, the Pascal triangle will have always ones in the beginning and in the end. How do we construct it? We are going to construct it adding or summing terms. In this case, we have 1, 1 and 1. How to construct the next level? To construct the next level, we are going to see if I add 1 and 1, we will get 2. If I add 1 and 2, we are going to get 3. We add 2 and 1, we are going to get 3. If we add 1 and 3, we are going to get 4. If we add 3 and 3, we are going to get 6. If I got 3 and 1, we are going to get 4. And we can continue to the n power, but that's a form of constructing the Pascal's triangle. So we can construct it and we can see that the numbers that we got in the Pascal's triangle are going to be the coefficients for our answer of the binomial to the n exponent. In this case, we can see like we have a 1, 2, and 1. So if we got x plus y squared, we are going to get 1x squared plus 2xy plus 1y squared. So that numbers we are going to help us to obtain the coefficients on the answer. Let's see in this case 1, 3, 3, and 1. So if we are going to do a binomial cube that we have seen it, it's going to be the first one cubed plus 3 times the first one squared multiplied by the second one plus 3 times the first one multiplied by the second one squared plus the second one cubed. So the Pascal's triangle will let us know the coefficients on every term when doing a binomial to the n power. Now, how can we know the exponent of the letters? It will be very simple. Here we can see like it says one term exponent will decrease from n to 0 and the other will increase from 0 to n. So if we see here we have x squared, then x, then it disappears because it's x to the 0. In the case of y, we have a y to the 0, it's not there, y to the 1, and y to the 2. So let's go with this one, x plus y to the fifth one. So it's going to be x is going to be 5, 4, 3, 2, 1, and disappears. In the case of y, it's going to be 0, that it's not there, 1, 2, 3, 4, and 5. So it's going to be very simple. The Pascal's triangle will let us know the coefficients, and in the case of the powers, we need to do the first one will descend in order of powers, the second one will increase in order of powers. So that will be like the explanation of how to use the Pascal triangle to know the coefficient, and also we can know the exponents for doing a binomial to the n power. So let's see some examples. So the first example is going to be something like this, a binomial to the 4th power. So we know we need to use this specific structure. So we know that it's going to be the first one to the 4th power, then it's going to be plus 4 times the first one to the 3rd power multiplied by the second one, then it's going to be plus 6 times the first one squared multiplied by the second one squared plus 4 times the first one multiplied by the second one cubed plus the second one to the fourth power. So in this case, we are going to obtain something like this. In this case, 3 to the fourth, it's 3 times 3, it's 9, times 3, it's 27, times 3, it's 81. So it's going to be 81 x to the fourth. In this case, maybe you can do it by mind, but I will do it in 2 steps. It's going to be 27 x to the third multiplied by minus 2y. Then it's going to be plus 6 that's multiplied 9x squared that multiplies minus times minus, it's plus 4y squared plus it's going to be, we can put it 12x that will multiply minus 2 times minus 2 times minus 2, it's going to be negative, it's going to be 8y to the third, and then 2 times 2 times 2 times 2, it's going to be positive because remember a negative to an even power, it's going to be positive, and it's going to be 16y to the fourth. So our final answer is going to be 81x to the fourth minus, it's going to be 27 multiplied by 8. So it's going to be 216 x cubed y. Then we are going to get 24 times 9 that it's going to be also 216 x squared y squared. Then we are getting 12 times 8. So it's going to be minus 96 x y cubed plus 16 y to the 4. That will be the correct order because x is descending order of powers. So that will be our answer for 3x minus 2y to the fourth power. So as we saw, it's kind of simple. It can be long multiplications, but it's simple. We need to follow the order that it's going to be, in this case, to the fourth power. So we need to have this specific structure in the coefficients, and of course the powers are going to be, in the case of x, 4, 3, 2, 1, and this appears. In the case of y, it is not there, 1, 2, 3, and 4. So it's kind of simple. So let's see other example. Before going to the example, we can see here, if in the binomial we have a positive and a negative terms, the signs are going to be alternated. So it's going to be plus, minus, plus, minus, plus. I know we can obtain those signs from multiplying these parts, but we can know that it will be always when we got a positive and a negative one, it's going to be positive, then negative, then positive, then negative, then positive, then negative. So let's see another example. So if we get something like this, something to the 6th power, so we will need this specific structure. So we know it's going to be something like this. The first one to the 6th power, then it's going to be plus 6 times the first one to the 5th multiplied by the second one, then it's going to be plus 15, that is going to multiply the first one to the 4th multiplied by the second one squared, then it's going to be 20, that multiplies the first one to the 3rd power, the second one to the 3rd power, then it's going to be plus 15, that multiplies the first one squared multiplied by the second one to the 4th, Then it's going to be plus 6, the first one to the first power, and the second one to the fifth power, and finally the second one to the sixth power. So we are going to get something like 2 to the 6 is 2 times 2, 4 times 2, 8, times 2, 16, times 2 is 32, times 2 it's 64. So we are going to get 64. In the case of the exponents, remember, if we got the rule of exponent or power of a power, we need to multiply them. So it's going to be x to the 18. Then we are going to get 6 that multiplies. It's going to be 2 times 5, it's 32, x to the 15 multiplied by 1. Then we are going to get 15 that multiplies 16, x to the 12, 1 to the second power, it stays 1 because it's 1 times 1. So it's going to be then 20 that will multiply 8x to the 9 times 1. Then it's going to be 15 that will multiply 4x to the 6 that will multiply 1. Then it's going to be plus 6 that will multiply 2x to the third that multiplies 1 plus 1. So our answer is going to be something like 64x to the 18. Then it's going to be 32 times 6, 192, x to the 15. Then it's going to be 16 times 15. That is going to be 240 x to the 12. Then it's going to be 8 times 20, it's 160 x to the 9. Then it's going to be 15 times 4, that is going to be 60 x to the 6. 6 times 2, it's 12 x to the third, and finally plus 1. And that is going to be our final and correctly ordered answer. So it's not difficult, it's only applying the specific rule for doing binomials to the n power. So we can do any binomial to the n power using the Pascal's triangle and only checking that the exponent of one letter will increase from 0 to n, the other one will decrease from n to 0. So now you are able to do the specific task of binomials to the n exponent.